Welcome to Python Programming Made Easy for Beginners. This is Lesson 2 in a video series, and it's entitled Understanding Syntax. If you haven't seen the first video, don't worry, I'll put a link in the description. Also, I'll put it at the end of the video, so when you get to the end, you'll be able to click on that and go to that video, which will tell you what you need to get started and how to install the Python software you're going to need for this series. My name is Brian Cafferkey. Please like, share, and subscribe to the channel. And if you do subscribe, make sure you click on the notifications button so that you can get notified when new videos come out. Also, I'm drinking out of my Pandas mug. And Pandas has significance in Python because it's a package used to extend the Python language so that you can do great analysis of data, all kinds of great stuff with it. It's a really powerful package and very popular. I'm also wearing my Python shirt because we're talking about Python, my signature hat, so I'm ready to go. Let's jump in. So where are we going to be going in this video? We're going to talk about what syntax is and why it's important. We'll look at Python syntax specifically, and we'll look at syntax versus coding conventions. And finally, I'll do a bit of a demo so that it's clearer what kind of things you can expect when you get errors in syntax. And then I'll wrap things up. So what is syntax? Syntax is the set of rules. I have to read this a bit, I have to admit. Syntax is the set of rules for properly writing a language. So two things at once I'll cover here. This is a great book. It's called Python Crash Course. I believe it's a second edition now. I think I have the first. But it's a great, if you want to go like kind of step by step, cover to cover, and follow with what I'll talk about. I'm not going to go by the book, but I will be covering the same concepts in the book. And it's a really good one in terms of stepping through programming ideas with Python and kind of builds complexity. So it is a good book. I have it. I paid for my own, and I don't get anything for recommending it at all. So it's a good one. I'll put a note at the end of this slide deck so that it actually refers where you can get this and etc., the name, that kind of thing. But one of the things I did want to point out also with when you write a book or do anything in English, there's a set of rules. Right, so you have to do certain punctuations. We use spaces to separate our words. We capitalize certain things. So in the English or Italian or French or any language really, there's going to be rules for syntax. So syntax is not something that is just this programming thing, although we tend to hear that word mostly associated with programming languages. Things to remember when you talk about syntax, and again, I'll use English because it's good to start with what you already know, which is whatever language you speak. And things that matter is, for instance, word order. If I say go, you, me, they, doesn't make a lot of sense. So making sure you put in the proper sequence of words is really critical to understanding what you wrote. Spelling matters. If I misspell someone's name, people may not understand who I'm talking about. Punctuation matters and formatting matters. We talk about spacing and things like that. It matters. The goal is to clearly communicate complete thoughts. That's when you are writing a book like this or War and Peace or whatever you're writing. It's really important that you write in a way that is clear so that people understand what you're talking about. That is true in programming languages as much as it is in regular written language. Now, without syntax rules, writing would just be gibberish. It would make no sense to anyone. So we already understand really the concept of syntax. Let's take that knowledge and apply it to Python syntax. I'm going to follow a little further though with English for a minute. If we think about English syntax, if I put something like this in front of you, it's not really clear what I'm trying to say, right? It's just a bunch of letters. It doesn't mean much. But if I put some spaces between it, suddenly now I can make out the concepts. I can take each word now and understand what you're saying. So the quick brown fox jumped over the fence. I followed it. That's great. What I'm doing is I'm separating it with spaces. Spaces matter. Spaces matter in pretty much all the written languages, certainly English that I can think of. Spaces matter. And it also matters a lot in programming. So you already know something. You know spaces matter in English and spaces matter in programming. Little tidbit, if I put one space or 5 spaces between a word, we tend to filter out the other spaces. We just want to know that the and quick are 2 separate words. And also, in Python programs as well, you'll find that if you put extra spaces between things, it doesn't really have an effect. Python just needs to at least have one space in most cases. Now, if we do a little bit more formatting, for instance, periods, and also we've added uppercase. Now, our brains are pretty smart. We can work around the idea of not having things in case. We do that all the time, right, with our text messages. But the periods are very clear because when you put a period, it says that's a complete statement or sentence. In a programming language, we say that's a complete statement. In English, we would say that's a sentence. The period tells us that's the end of a sentence, and the capitalization is kind of reinforces that to say here begins a new sentence. So we've got this idea of periods also. What we're really talking about here is something in programming they call delimiters. Delimiters mark things as separate. If you've ever used Excel and you heard of CSV files, comma separated value files, commas are typically used to separate different columns in a file. If you haven't, that's okay. I just want to use a reference in case you know it. Similarly, spaces, we just discovered, are delimiters. Periods can be delimiters. A new line, meaning you do another line, is also a delimiter. If we see a new line in a file, like the quick brown fox jumped over the fence, new line, I followed it, we tend to treat it almost like a period. It's a complete statement. And you'll learn Python's like that too. It doesn't like it when you try to do two things that are completely different without a new line. So a new line is really more like a period than anything in Python, and we'll see that. I want to emphasize there are a lot of like special characters. We can think of in writing, like we don't use things like tildes over our letters, but French and Spanish use letters, like, things like that, symbols. We have backslashes, we have @ signs, we have pound signs. And if you think about, like, what is a pound sign? Well, we think hashtag, right? And we think we use that in Twitter. These things have special meanings in most programming languages, definitely in Python. So be careful when you use non-letters and numbers in your code. They will have a special meaning typically, and you have to know when you use them. And we'll see that as we go, but I wanted to point that out. So from Python to a computer program, this is our lovely Python code. Now you don't have to worry about what it's actually saying here, but it's written in Python. The first thing you should realize is Python is actually in the English language. It's meant to be understood and read by humans. This is probably one of the first mistakes people make, including myself when I first started programming. I thought I was learning a computer language. You're not. You're learning a human language that can be translated into something the computer can use or understand. And that's a key difference. So the good news is all the programming languages you've ever heard of, from BASIC to Ruby to Perl or whatever, are meant to be understood by humans. They're meant to be readable by us. But they're structured, their syntax is defined in a way that allows it to be translated so that the computer can understand it. Because the computer, on the right here, speaks machine code. And it's a really strange thing to get your head around, but the only thing the computer really understands is what's called binary, zeros and ones, which are really just charges on the computer memory. There's a charge or there's no charge, off, on. So it's really called like a switch. And by billions and billions of these switches, it can actually run a program. Crazy as that sounds, and it seems like not a lot under the covers, it gets down to that simplicity. However, getting from this English-based language to the machine code requires something to translate it, to be an interpreter. So if you think of somebody working at the UN and they speak one language and somebody else speaks another, diplomats, they often have to have an interpreter who's translating English to French or Spanish or Chinese. And that interpreter is what happens in Python. Python code goes in and it's taking what you're typing. And remember the last video I did one console, one command at a time in the Python console. And as I entered each command, it would be automatically translated and executed as machine code. So that was happening. When you do a file, it's just sending the file in line by line, which is being translated into machine code and executed. All programming languages must be translated to machine code before they can execute. And there's various architectures to do that. But Python's approach is to use an interpreter. So you write it one way and it interprets on the fly and translates to the machine code and runs. Now personally, what you will probably find, if you're like me, is that often I'm like this guy with my hand saying, why won't this program just do what I want? Now I know I'm making a mistake and it's complaining, and sometimes I can't figure out what's wrong in my code, and I'm still waiting for that interpreter that does what can read my mind, right, and do what I want, not what I say. Okay, yeah, I said it wrong, but do what I meant. Now the interpreter takes things literally, as a computer does. Computers have no intelligence in them. They only have rules. The interpreter has certain rules for syntax. If you don't follow them, it doesn't understand. I want you to think of it like a little puppy, right? You've got this little puppy, it's cute, maybe it's a little beagle with its tail wagging, and most of the time when you talk to that puppy, it sounds like wah, 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 and the dog's just looking at you. It's happy, it wants to do what you want it to do, but then you say something like wah, 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 Fido, wah, 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 and it understood one word, Fido. It gets all excited, it understood something. And maybe after a while you've taught it a few things, or it's just learned to associate a word like walk, because I know I have had dogs in the past, and they always learn that word, walk, and then they run to the door and they're excited, they want to go outside, so they know walk. And eventually they learn other things. They learn that when someone says dinner, for instance, they may actually learn, oh, food's around. Again, they learn certain things, but they only know certain words, and the computer, the interpreter, is the same way. It only understands certain words. They're really pretty dumb when it comes to understanding code. Hence the frustration you will probably feel when you feel like it should understand what you've written. It's not very intelligent, is it? Interpreters are not meant to. It's up to you to get the code written the way it requires. And that, if you don't, well, you're out of luck. It won't run. So let's move on. So let's stop. And I like to think about Taoism and Zen Buddhism. It's one of the things I kind of like to think about philosophically. And there's an expression called, when you're playing a game, be the ball, which is by being present and being fully focused on trying to be there with be the ball. I'm saying, well, be the interpreter. What do I mean? Try to imagine when you're writing code that there's this other program, the interpreter. It's just a program. And that interpreter's got to read what you wrote and convert it, as we said, into machine code. So it's really not easy for it to do things if you type things wrong. It's not going to understand when you make mistakes in your code. You're not playing by the rules. It's not the interpreter's fault. I have blamed the interpreter many times, but it's not really the interpreter's fault. Unfortunately, it falls on you. You have to get the code written correctly. That's just the way it is. So if you can start to think a little bit like the interpreter and understand what it's looking for, if you were to write a program trying to parse out what's going on in your code, one of the key things you're going to be doing is looking for tags, looking for little markers, new lines, looking for commas, looking for periods, as we mentioned, the syntax, because you need to break it all up and then turn it into machine code. So you really need to be able to parse through it. So for instance, in Python, indentations are critical. It's the only language I know of where indents actually are used and matter. They're not ignored. They create a hierarchy of your code, and Python is very sensitive to that. In fact, if you don't even indent on the right boundary, the right number of characters in, Python will give you an error. When you indent, it has a lot of meaning, so be aware of indentation. Periods. Periods are also significant. Depending on what you're doing, they can mean different things, but here, and you don't have to understand the details, but we'll talk about this later, but it indicates that we're calling a function, a block of code, and the period is separating what's called an object from a method, okay? Not to understand the details as much as to understand that it's separating two pieces, so that period really matters. Colons matter. I tend to think of colons in Python more like semicolons in English, because when I put a semicolon, I'm going to follow with more that belongs with that sentence. In a similar way, a colon is like, I've got more to say related to this, and it will follow. Parentheses are used everywhere in Python, and that's because they have a lot of purposes. In mathematical operations, you will put parentheses around things to structure the order of operations, just like you would in math. In other cases, as you can see here, we're executing code, and parentheses are used to mark that. Now, what you need to understand about parentheses whenever you use them in Python is there's a beginning parentheses, there's an ending parentheses. These are like bookends, and they must always go together and match. If you have two left bookends but only one right bookend, the code will fail. You'll get a syntax error. That's because when Python sees an open parentheses, it says, I'm looking for the end of whatever you're putting in here, and there can be a lot of code in between your beginning parentheses and the ending parentheses, but it's going to take that all as one sort of chunk, one piece. So as soon as it sees an open parentheses, it's waiting for you to finish and close off the parentheses. It's like saying, I know this great joke, and you just kind of wander off, and people are like, well, what's the joke? You've opened it up, finish it. In a similar way, when you open a parentheses, you're telling Python, I got something coming, and if you don't close it, or if, let's say, you have a mismatch, it's like you said, I got this great joke, I got a new hat. You just did something irrelevant. It's waiting for those parentheses to match and everything to line up, and the world will be whole and everything's great. So parentheses are really key, and honestly, it is a place for confusion because very often we tend to do things which require us to nest parentheses. You might have an open paren, open paren, open paren, and you've got to make sure they match going out. The integrated development environment can be a huge help here, and so it will help you by telling you when things like this are not correct. But be aware. Now, case matters. The case being upper or lower case. One of the tricks to understand in Python, and a lot of languages, but not all. Windows languages don't always follow this, but in most Linux-based languages, upper and lower case are very different. So if I spell something, Brian with an uppercase, it is not the same as Brian with a lowercase, the lower B. So understand that because it can be confusing, and if you start mixing cases, it can trip you up because you may forget how you spelled it, and there are different things, and you'll get syntax errors. However, case usage can also be, and usually is, part of a sort of programming coding standard in an organization. Python has actually quite a few conventions, recommended things. The interpreter does not care, mind you, but they call it, you've heard being Pythonic, and they actually have a set of coding standards called PEP 8, which Python programmers are advised to follow, so their code's readable, not so that it runs better. But that's an important understanding. The other thing I wanted to call out here is we haven't even talked about the language, right? I mean, in English, we have things. We have mice, and we have cups, and we have pandas, and we have all these things. But there are some things, if I said blah, 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 it doesn't mean anything in the language. If I said pussyfoots, that's not a word in English, right? So you don't know what to do with that. When you have certain Python significant keywords, that fires up. That's like little Fido there. Door, walk, dog gets all excited. There are keywords it recognizes. Python also has a list of words. It has sort of a dictionary of words. I know these words. I'm really smart. But there are other words it doesn't know. That's the Python language. That's the part where it becomes a language. So if we look in this sample of code, one keyword is return. Return has a specific meaning. You see the DEF, which is short for define. That's also has meaning. Class has meaning. So all these things are part of the Python language. So the trick is following the syntax rules, spacing, punctuation, etc., as we use the Python keywords, the commands, and then also tailored to what we're trying to do. A lot there to unpack, I know, but I want you to just have a feel for what's happening so that when you make a mistake, you can kind of say, oh yeah, I forgot the colon, and that means it's getting confused, or parentheses. The key thing to look is the right here, you see the little computer. Think of it like your puppy. Brian, what are you trying to do? What do you want me to do? The computer is sitting there like this little puppy wanting to do whatever you want it to do. And as we know, computers can do a lot. They're eager and happy to do what you want, but you have to tell them in a way they understand. Otherwise, you get this syntax error, unrecognized word, error. So you do have to be aware of that. And syntax errors are going to happen. I want to encourage you to pat yourself in the back when you get a syntax error, because you are now a programmer. If you haven't had a syntax error, you haven't programmed. And if you get a little bit frustrated with syntax errors, you're even more of a programmer, because we all do. All programmers hit syntax errors. Later, you get to experience a more painful type of error called a logic error. But right now, you can just have fun with those syntax errors. I laughed. No, I'm just kidding. But if syntax errors seem a lot less troubling than logic errors, because that means you really messed up how you were thinking. All right, so let's jump in. Syntax is for the computer. That's the rule here. Syntax. Say this now. The syntax is for the computer. It's not for other people, which means when we're doing this, the interpreter needs these syntax rules. Now, kind of walking through this. Variables, I haven't introduced them yet, so I'll just give you a quick introduction. You've done algebra, hopefully. You see something like x equal 5 and y equal 2, and then you say something like x times y equal 10. Let's hope I did my math right. That's algebra, right? A variable would be like x, which you said is 5, and y is a variable which has 2. In this case, number, right? We have a variable number. So that's the thing. We're declaring variables. So this is the way we would declare a variable in Python. So that's when it sees this, Python automatically knows, the interpreter knows, oh, we're creating variables, and we're assigning it the equal sign 8 says we're giving it a value. So we're creating a variable number, and we're putting 8 in it. Then we're creating a variable guess, and we're putting 0 in it. Yay, you just learned some coding. That's syntax, and it's important to do that correctly. Now we get to this key word, right? While. While is a Python language keyword. It's a command. It means something to Python, like when you say Fido sit, Fido sits. When you say while to Python, it's looking to do something. It wants to do something. Now in this case, the while statement creates what's called a loop. We'll talk about that later, and I cringe a little bit to give you too much, but I want to give you a sense again of syntax. While says, I want to repeat some lines of code. I want you to run these multiple times. The idea behind it is, I don't want to have to type this 50 times over and over again and to do something. Why not just say, look, I want you to do X, so do it, and I'll do it X number of times, something like that. I want you to repeat this. So we're setting up what's called a while loop. I'm not going to get too caught up in it, but we want lines after this statement, while condition, we want those to be executed multiple times. We tell Python that by putting them together by an indent. The indentation tells Python that the lines after the while, these are the ones that should be considered to be part of the while loop. The two statements after that should be outside the loop, meaning that once that loop is done, it's kind of like, think of it as, go over there and do something and come back. Well, once that's done that loop and comes back, then it's going to continue on the program, and it'll print nothing, the second to last statement, and then prints thanks for playing. So that's outside the loop. Notice that the print statements after the loop are actually pushed back out to the left margin. They're not indented because they're not intended to be part of the while loop. Now, kind of looking a little more detailed here, if you look at the if condition, we have an if. Don't worry about what it means. We'll talk about that later. But we conditionally with the if, we have the print statement. It's indented because we're saying if something is true, then print this. Again, we indent. Indentation is really key. If we were to push that out to the, say, directly under the if, Python would actually get confused. It'd say, wait a minute, I'm waiting for conditional stuff here, and you didn't give it to me, you didn't indent. If you pushed it, and a really odd thing about the syntax is if you were to just be one character off on this indent, say that print was one character to the left, Python would actually fail and say, you didn't put this on an indent, I don't recognize this at all. So indents are really key. That's really the only thing I want to get in your mind is the importance of indentation. We talked about colons. You'll see that here we've got a situation where we're saying something like while, and then there's lines that are dependent on that statement. It's fairly common in Python. When you do those types of statements, they end with a colon, and that tells Python to keep looking for the rest of it. So you see it there, and you can also see it where if condition, at the end it says if exclamation equal number colon. The colon says look for the execution code based on this condition. So the idea there is the colon is saying to the interpreter, look for the rest of it after this. It's kind of like, let me give you a list of items to do, and then 1, 2, 3. So that colon is like, here's my list, or something like that. It's something to say more follows. We see at the top, there's author, Brian Kafke, purpose. These are called comments. That, and there's a pound sign or hashtag, and then a statement. First time you assign blah, blah, blah. Those are comments. Now what you need to understand about comments like that is the interpreter doesn't care about them at all. You don't need to include them. The interpreter will actually removes them. It won't even process them. As soon as it sees those triple quotes wrap around, triple quote beginning and then triple quote at the end is basically just a big mark that tells Python it's a multi-line comment and I'll ignore it. When you have a single line comment, you just put a pound sign and whatever you want to say. So comments are ignored. That's why they look regular English. They don't look like Python code. So don't try to read comments as if they're code. You'll just strain your head. It's not worth it. Comments are for people to read. That's meant for people, not the interpreter. I want to step back and talk about coding conventions. Coding conventions have nothing to do with the interpreter. Coding conventions can be ignored. You will not be considered a good programmer. You might be considered a hack, but your code can run because the interpreter really doesn't care. You can squish it all up. As long as you follow the required syntax requirements, Python's happy. However, it's important when you code to make sure you can read your own code, others can read it, and that you can make changes to it and understand what you did. So there are ways of writing code that are understandable, and those are coding conventions. Python is really big on this. I talked a lot about it in my last video because Python was written to be, more than any other thing, readable. Code is maintained and modified a lot more than it's written. So we have lots and lots of code out there that has to be maintained. That's where the jobs in programming are. Again, it's not something programmers like to talk about. The glamour is in writing all new code. I'm going to write a new, big app. But the real work, 80% is probably going back to code that's been written and making changes, enhancements. That's why you see all these fixes, bug fixes, and new enhancements. That's maintenance. So let's take a look at coding conventions. Well, the way you declare variables, that's syntax in Python is required, but whether you use upper, lower case and stuff, that's a coding convention. So here, we're using lowercase for our variables. We've got extra blank lines. Now, having a blank line, having a carriage return before another statement in Python is a syntax requirement. But if you want to add 2 or 3 extra blank lines so that you can kind of get some spacing, because white space helps us read better, we can see things better. That's why we put white space between paragraphs in English. So here we can see we've got some blank lines. That's fine. It's a coding convention, not required, and really different coders use different conventions. I like to put lots of blank lines just to make it more readable, but a lot of people put less, and that's really arbitrary. Comments. Comments are a good idea to explain things that may not be easy to understand for people, like what you're trying to do, maybe some formula you're using or whatever. A lot of times back in the day, people put author and purpose. A lot of these things are, taken care of by other ways, but the idea of comments is just to provide additional information so for people who want to read your code. Now, the person that may most need to read your code, and you may be surprised, is you. 6 months or a year from now, you may want to go back to a program you wrote and you won't be able to figure out what you did. I've done that more times than I can count. Fortunately, I usually now have learned put comments in and try to make it readable, and then I can follow what I did, because it's really interesting. A year from now, you go back at a program and say, wow, I must have been really smart back then because that program looks cool. I have no idea how I did that. That's one of the joys of programming. Meaningful variable names, again, is standard. Rather than just saying, you could say, I'm calculating something. Imagine, again, algebra. We're going to set up something. We're going to have principal, and we're going to have calculate. We're going to have principal, we're going to have interest, and we want to calculate the amount of interest. So we have interest rate and principal, we'll say. Well, we could create a variable interest rate, and we could create a variable principal, and then we could create a variable which is the result of multiplying the interest rate times the principal, and we get interest paid. Great. If we use names like that, it's really easy in the code to understand what you're doing. But if you say A is principal, B is interest rate, C is the interest paid, that's going to be really hard for people to make sense of in your code. And mind you, these are little small snippets of code, but when you get into large programs, that kind of thing will get you a bad reputation very quickly, and you will not be considered a good programmer. People will run from you, so you don't want to do that. Now, I talked before, the computer saying, what are you doing? Imagine you go work for a company. You did great. You learned Python. You're sharp. They hire you. And the first day, and very likely this will happen, they'll say, okay, Brian, there's some programming stuff someone wrote. We had an intern, Mary. She did a great job. She wrote some programs for us, and we need you to go and make a change to this program. You're going to go in there. You've never read this program. This person doesn't write the way you write your code. Every programmer has their own style. So this programmer has their style. Now imagine if that programmer did things like I said, like A, B, C for variable names. No comments at all. You can't even tell Mary wrote this code. You don't have any kind of reference. And she took a lot of, she crammed things together, right? No white space. If she did that and you're trying to read it, you're going to get frustrated. You're going to be like, oh my gosh, what is this person doing? I always think when I'm writing code that the impression I'm making on another professional is through the code I wrote. And I like to imagine in my mind, I've always done this, but I imagine in my mind, like they're going to look and say, okay, this is good, this is clean, I like it, thank you, Brian, it's all laid out, makes sense, great. You know, thumbs up, great job, I appreciate that. On the other hand, you might be more like this, Brian, what are you doing to me? You know, I thought I was going to go home early. Now I'm stuck here trying to read your horribly written code. Nothing will get you a bad reputation as a developer, especially among developers. Management, they don't read code, but developers do. And if they see code like this, it's not going to be good, and you're going to have a bad reputation. I should also warn you that sometimes, not too common, but some programs will actually seems to write bad code really for job security. Like I'll make it so confusing nobody else can understand this except me. Good news is they don't usually end up with jobs very long because management and programmers don't want to work with people who write code like that. So this is important. However, your challenge, you know, I think of Mission Impossible, your challenge, should you decide to accept this assignment, learn Python, learn syntax. That matters more. We'll talk a lot about coding conventions. We'll get into that. You'll learn it. But more importantly, you got to get your program to run. So I don't want to overload you with this. I'm really focusing on this because you might confuse these conventions with syntax and make your life more difficult. So let's take a look at syntax errors for a minute. Now go to my DOS prompt, whatever command prompt, depending on your operating system, go there. I'm going to a command prompt in Windows. And as we did in my last video, we're going to go into idle, named after Eric Idle. Idle is a integrated development environment, basically a text editor with a terminal, and it comes with Python. I'm going to go to a file I had, and this has a couple of coding errors in it, and I just want to show you what it looks like. So I'm going to go through the pain of getting a coding error before you have to, but also to show you like how silly they look and kind of give you a feel for this. So I'm going to go here and say run module. And notice right off it says unmatched, and you can see a right parentheses. If you look at the code it's highlighting, it's showing that I've got a right parentheses and then a right parentheses again. I never had an open parentheses. Fortunately, it's pretty clear. It's telling us a syntax error, and it's pretty clear what it is. They're not always that good, but we'll say, okay. So let's fix that. And I'm going to save the program because if I don't, it won't run it because it's going to submit this program, the whole file. I'm going to run this and say run module. Now I get something different this time, right? You get this whole wonderful. Now, mind you, notice it's submitting the program. That's the name of my program. Trace back. It's telling me about that. It's telling me the errors in line 5. Let me try if it's right. 1, 2, 3, 4, 5. So it doesn't like something in this line. All right, now I know at least where to look. It's really key in debugging a program to know what line you're at, because if you got a 20,000 line program, it's not easy to scan through it to find out where an error is. So it's good if you can get down to a line number. Now it's telling you, I don't know what Y is. This is actually a pretty good error too, though it probably seems confusing to you. It's saying name error. What the heck is Y? It's not defined, and you can see right here Y. Well, let me go back here. Oh, I'm using uppercase Y, but my variable I want to reference is lowercase y. That is not okay. That's not according to our syntax rules because case matters. So we're going to change that. Now I hope we're good. I'm going to save this. I'm going to go to run the module, and it runs. This whole thing is just telling me it's running the program, but my output is this. I didn't really print anything, but just the result of these. So we can see that it ran. Now let me close this for a minute. And we'll talk about syntax here and what we're doing later. You're going to very soon get into variables. But the important thing to understand is It's very particular, and single characters, things like that, seem confusing, but it makes sense because, as I mentioned, as soon as you have a begin parentheses, Python looks for the close, and they must always match in pairs. Also, case sensitivity, if I use uppercase in one and lowercase in the other, you're going to get an error. So when you're writing a code, you're always going to be like, come on, just work, just work, just work. But you'll get there. And when you get an error, again, pat yourself on the back because you're now in the company of programmers and you're experienced the real world of programming. I'll take a slight aside here to say the key to being a good programmer, or the key to sticking it out, because there's a learning process. I didn't stick it out with golf. If you see my other videos, I gave up. Golf isn't for me. The pleasure of doing well in golf is less than the pain of playing golf. Programming is also like that. You must get enough joy and pleasure from successfully getting the program to work that you forget about the pain it took to get there. And that's the secret of all programmers have. If you don't have that disproportion, then you're probably not going to stay with programming because you get too frustrated. But give yourself time, get excited, pat yourself on the back, reward yourself when you got a program to actually do what you said it should do, what you wanted. That's an accomplishment, that's an achievement. And getting excited over that, which is what I do, makes me forget about many hours I may have taken to make it work. Now in the beginning, you shouldn't have hours and stuff, it should work. I just want you to get a feel for that you're going to have some of that frustration. It's normal. It's all what developers all go through, so don't worry about it. So wrapping up, we talked about what syntax is and why it's important. And I talked about English syntax and the fact that, or French for that matter, that there are rules for how we must do written language to make it intelligible. And we know that computers are no different. And that's why it's important, because if we don't follow those syntax rules, we get errors. And I really want to try to help you not get too stressed out from errors, because I know they can be confusing in the beginning. Python syntax has its own rules for its language. It has its own keywords and certain things like we talked about periods and commas and semicolons and upper and lower case. We saw some of that. Python has its own rules, and the important thing to understand about syntax for Python is it's the interpreter that's requiring those rules because it needs to make sense of what you want to do. We also talked about syntax versus coding conventions. Coding conventions include things like, meaningful variable names, maybe upper and lower case standards for variables and objects, whatever we're creating, comments in our code, etc., etc. And coding conventions are important, but they're not something you want to, get too bogged down early on. You have enough to worry about as a beginning programmer to understand the syntax and getting a program to work. That's an accomplishment. That's reasons to go out and celebrate. And I did a short demo kind of demonstrating the kinds of errors you can get when syntax is wrong and ways to kind of back into using error messages to sort of fix that. And I'm going to demonstrate more of that as we go along. I want to try to work that into the lessons without making it something completely separate, because it's going to happen as you go, not all at once. So there's no way to really upfront and upload that training. I'll work it in. And this is the book I recommended. It is a good book. As I mentioned, I have a copy. It is pretty thick. It starts at the very beginning, but it actually shows you as it gets deeper how to do different types of programs like games, even web development, which is a little beyond, I think, this book, but all those things. Eric Maths, I think is the way you say his name. It's by No Starch Press. I don't know what it is about No Starch Press, but they have some really great books. There's one, The Art of Our Programming, which I really love as a book. So they have some really no-nonsense but good books. This is definitely one of them, so take a look. So again, I want to thank you for watching. Anything what you want to know, feedback, questions, please use the comments. I appreciate if you would like, share, subscribe, click on notifications, and keep on programming. We're all in this together. I'm pulling for you. Reference from the Red Green Show.